Okay, this is section 7-4, the double angles and half angle formulas. When we look at these double angle identities, these are derived from our sum identities. If you think of the sine of some angle, we'll call it theta, plus theta itself, so that's sine of 2 theta, then this could be written as the sine of theta times cosine theta plus cosine theta times sine theta. So this just becomes the sine of this double angle, because it's itself, 2 times theta, and that all equals just this sine cosine, because they're of the same angle. So it's just really a specific case of your sum identities dealing with the same angle, and that becomes your double angle identities. You'll see the same thing here for cosine. Again, of 2 of the same angles, when you add them together, you get cosine theta times cosine theta minus sine theta times sine theta. So this then just becomes the cosine of 2 theta equals cosine squared theta minus sine squared theta. Now, one caution here, common error is to think of this as your Pythagorean identity. Notice that this is a subtract or a minus symbol, not a plus, so this does not equal 1. So let's use these and take a look at a couple examples. So if I've given the sine of an angle is -2/3, and that angle is found between 3π/2 and 2π, so this is going to be in quadrant 4. So my triangle then would be something over here. And I've got the sine ratio. It's -2. And remember, sine, we've got our SOHCAHTOA. Our sine is the opposite, so that's my -2 because I'm in this quadrant. And then the hypotenuse, which is 3. So I'm going to use my Pythagorean theorem here in order to find the x value here, which would just be, we'll call this a squared plus -2 squared equals 3 squared. So I have a squared plus 4 equals 9. Subtract 4 from both sides and take the square root, and you've got the radical 5. So then I know that the cosine of this is going to be equal to radical 5, the adjacent side, over the hypotenuse. And I'm asked later for tangent, so we'll find that one as well. The tangent of this angle is equal to the opposite over the adjacent. That's going to leave us with the radical in the bottom, so I'll rationalize that by multiplying top and bottom by radical 5. So I'll get -2 radical 5 over 5. And that'll be my tangent identity. So, if I look at the cosine of twice this angle using the double angle formula, so that's going to equal, and I can pick between really any of the formulas that you saw up above. They're just rearranged, substituting in for either cosine squared or sine squared. So perhaps it's sometimes easiest to pick the one that goes with the value you have. You see, you do have a formula back above there that just deals with sine squareds, and you have another one for cosine squareds. So since I'm asked for the cosine of 2 theta, and I have the sine, that's what was given to me, I can use the identity that cosine of twice the angle equals 1 minus 2 times the sine squared of the angle. And since I already had the sine, I begin to rearrange this, and the sine of that angle was -2/3, that quantity squared. And then really from this point, it's just substitution, and we're just simplifying. So I have -2, and I square both top and bottom, so that's 4/9. Multiply it by the 2. So it's 1 minus 8/9. Find a common denominator, makes this 9/9. So that leaves me with 1/9. and that is the exact value of the cosine of twice that angle. We do the same thing here for sine. Sine of twice the angle is equal to 2 sine times cosine of the angle. And then we just substitute our values. I know what the sine of the angle is. It's negative 2 over 3. And I know what the cosine of the angle is. I found it by setting up my right triangle. That's radical 5 over 3. And then we just multiply through on all of these. If I multiply the 2 through first, I get negative 4 over 3 times radical 5 over 3. And then when I multiply these two together, I get negative 4 times radical 5 over 3, and 3 is 9. And I look to reduce, but that's as simplified as it's going to get. Now these can be evaluated on a calculator using our sine, cosine, tangent, and our inverse in order to find the angle and then double it. But what we're really doing here is we're using these to find the exact values. And then if I look at the tangent, and this should be of twice the angle, that's going to equal 2 tangent of the angle over 1 minus tangent squared. And then again, it's really about substitution in these problems. So I get 2 times the tangent, which is negative 2 times radical 5 over 5. All that over 1 minus negative 2 radical 5 over 5 squared. And then this just requires some simplifying. I'll multiply the 2 here, which is going to get me a negative 4 radical 5 over 5. I'll square this, which is going to reduce down ultimately to 1/5. This comes into the 2, which makes it a 4, and this is a 5, so this is 20 over 25. And if I have 1 minus 20 25ths, which is 4/5, that's going to leave me with 1/5. We'll multiply, I'm running out of room here, we'll multiply by the reciprocal of that, which is 5 over 1. And this is all going to cancel down. We'll cancel your 5 there, and you're going to get negative 4 times the radical 5. And let's skip down to the next section. We'll take a look at those. So a similar set, but now I'm given cosine of an angle and a different quadrant. This is between pi over 2, which is 90 degrees, and pi, which is 180, so that puts this in quadrant 2. So if I draw my triangle, and I'm given the cosine, my SOHCAHTOA cosine from here is my reference angle, is going to be the adjacent, and this is in quadrant 2, so this is a negative 4 over the hypotenuse, which is 7. I'm going to use Pythagorean Theorem, so I get 7 squared, which is 49, take away 16, 4 squared, and square root it, you're going to get the radical 33. So then if I wanted to go ahead and write down cosine formula here, if I were going to use sine for this, I'd plug that in, that's going to be radical 33 over 7. So the cosine of 2 theta, twice that angle, I'm going to express this one as 2 times the sine of the angle times the cosine of the angle. And then we were asked to find the sine. This was a formula for sine. I miswrote that. So then the sine of twice this angle, and we begin to substitute the values, 2 times the sine of that, which is radical 33 over 7, and then times the cosine of that, which they told me is a negative 4 over 7. We multiply. I'll do 2 times the negative 4. So I get negative 8 times the 33, radical 33, over 7, 7, which is 49. Look to reduce, and that's as simplified as it's going to get. Negative 8 times radical 33 all over 49. So that does it for some double angle formula identities. Let's look at the half angles. And we have the half angle, or the sine of a half angle, is equal to plus or minus. This plus or minus just depends on which quadrant, so you need to pay attention on where that angle is at. And for the sine values, then, if you're in the third or fourth quadrant, down on the bottom side of the x-axis, you have negative values. If you're in the first or second, you have positive. Cosine, then, would be if you're in the second or third, you have negative. First and fourth, you're positive. And then tangent with its respective quadrants would be plus or minus. So that's where that distinction comes from. And then, as you see, pretty much similar formulas all the way across. Plus a cosine, minus cosine, plus cosine, minus and plus on the bottom. And which follows our form, sine over cosine. I have the sine here, the minus over the cosine here. No real need to memorize these. You have a formula chart. As long as you can apply them, that's all that we're looking for. So as I look at some of these examples, to find the sine of a negative pi over 8. So when I think about that, pi over 8, if you look at your formula chart, you might not be familiar with exactly where that angle is. I can make the conversion so that I can figure out where it would be in terms of degrees, but I know at 90 degrees I'm pi over 2, so halfway between that would be pi over 4, and that would be 45 degrees. Halfway between that would be pi over 8, which would really be like 22.5 degrees. So that doesn't sound like a very nice number, and I'm not quite sure how to find the angle. And this is where these come into play. I can't add two angles to do that. A double angle to get to 22.5, I'm not able to do either. But what I can do is I could take the half angle of 45 degrees in order to find what pi over 8 would be. And so a way to think about this is what we're doing is we're taking the sine of the half angle, which is negative pi over 4 over 2, or 1/2 of negative pi over 4. So that's what we see right here. I have my angle, and I'm taking half of it. This is my angle, pi over 4. And if you think about that pi over 4, it's negative, so it's rotating in this manner, and pi over 4 is 45 degrees. But I'm going to take half of that and actually calculate the sine value for a negative 22.5 degree angle. So until we had these formulas, we weren't able to formally do that. So I know that I'm using this formula. I'm going to go ahead and set that up. It's the sine value, so I know that I'm actually going to have, it's corresponding to the y. I'm in this quadrant because it's a negative. I'm looking for a negative 22.5 essentially angle. So it's going to have a negative sign on the outside. So we'll just work it straight through and then know that I'm applying this minus sign at the end. So the formula 1 minus cosine of the angle all over 2. Think about where this value is going to be on your right triangle, 45 degrees. We know that is the opposite over the hypotenuse, and for a 45, that is going to be radical 2 over 2. So this is actually a negative radical 2 over 2. And now instead of multiplying, or excuse me, dividing by 2, I can think of it as multiplying by 1 over 2, or I could multiply everything by 2 in order to clear this from the denominator. So I'm going to multiply everything by 2 over 2, and what this is going to do is distribute through. That's going to give me a 2 minus, that'll clear that 2, so minus a negative radical 2. So that's going to be plus radical 2, and then that's over 4. Now this whole thing is being square rooted, so I can simplify this down if I take the square root of the 4. This is going to be a negative on the outside because I'm in quadrant 4 and we're talking sine. Then I'm left with 2 plus radical 2 on top. and that's all over 2 because I square rooted the 4 to make it a little simpler. And that's my sine value for the half angle here of negative pi over 4. Okay, let's look at pi over 12. Change colors here so it doesn't mix. And I can think of this again, pi over 12 on my unit circle. I'm not quite sure where that is. I know it's in the first quadrant because 90 degrees pi over 2. And I'm familiar with pi over 6, which was going to be a 30-degree angle. So this would be half of that. So this would actually be 15 degrees. So I'm going to write this as the cosine of pi over 6, my 30-degree angle, and 1/2 of that angle. So if I actually divide by this, it's the same thing. Pi over 6 over 2 is pi over 12. I've just chosen to express it differently, which allows me to apply my half-angle formulas. And then I know that pi over 6 is my 30-degree angle as a reference in the first quadrant, so I'm going to use the plus sign in this case. And then the cosine of that, which is the x, in this case, the cosine of pi over 6 is equal to radical 3 over 2. And then we'll just go ahead and plug it in the formula. So I have the cosine of this half angle is equal to, it's going to be the positive value of the square root of 1 plus radical 3 over 2 over 2. And then I just do some combining here. Again, I'm going to multiply top and bottom by 2 over 2. That's going to clear this fraction here under the radical, and then make this something that I can actually take the square root of. So distribute this, I get 2 plus, these cancel, radical 3 over 4. I'll take the square root of that 4. And this all breaks down to the positive value of the square root of 2 plus radical 3 over 2. So really it's just a formula. We're substituting and then simplifying. And let's look at one more with the tangent of 15 degrees. So the tangent of 15 degrees, again, as we saw up in the cosine of pi over 12, I can think of this as the tangent of 30 degrees, which is a known value, and then take the half angle of it. So I'm going to write this as the tangent of 30 degrees and take the half angle over 2. So 30 over 2 is my 15. And I should know that 15 degrees is in the first quadrant, so the tangent of 30 is equal to, when I make all the changes, radical 3 over 3. So this is going to be the value that I'm going to end up substituting. And actually, that's the tangent of 30. My formula actually calls for the cosine, and I just dealt with cosine of the same angle in the last problem, so this I know is radical 3 over 2. So this is actually what's going to be substituted into the formula. So when I begin to fill that out, I have the square root of, and I have 1 minus cosine of the angle over 1 plus cosine of the angle. And then we'll go ahead and start to sub in our values. 1 minus cosine of 30, radical 3 over 2 over 1 plus radical 3 over 2. And first thing I'm going to do again here also is I want to get rid of these fractions, just clean it up a little bit. So I'm going to multiply top and bottom by 2 over 2. And that's going to break down to the square root of 2 minus, those cancel there, radical 3 over 2 plus radical 3. And now, some textbooks will stop there. We really don't want the radical in the denominator, so we're going to go ahead and attempt to rationalize it, and we're going to use the conjugate pair to do that. So over here, I'm going to rewrite that, 2 minus radical 3 over 2 plus radical 3. I'm going to multiply top and bottom by 2 plus, 2 minus square root of 3. And then when I do this, I have to FOIL this out in the top here. I'm going to get 4. Then I have minus 2 radical 3 When I come back here, I'll have minus 2 radical 3, so that's minus 4 times the square root of 3. And then minus times the minus is plus. Radical 3 is plus 3. And that's over. Same thing here, FOIL. 2 and 2 is 4. This will be minus a 2 square root 3, and then plus a 2 square root 3, so those cancel. That's your difference of squares. And then minus radical 3 is 3. And this is all being square rooted. Simplify a little further, and I have 4 plus 3, so this is 7 on the top there, minus 4 square root 3, and that's all 4 minus 3 is 1. So that got rid of everything down there. So it's really just the square root of 7 minus 4 radical 3. And then again, this is tangent. We are in the first quadrant here at 15 degrees. So that's positive over positive, so we are on the positive sign. So this is our solution here. And we'll stop there. You'll have a problem set on Monday. We'll work in class. If you have any questions over this, we'll clear them up at that time. And have a great weekend.